Okay, so that's good, but I keep being frozen. Like I see myself as frozen. So I'm gonna need you guys to every so often just like respond to what I'm saying, just so I haven't completely lost everyone. Yay. We love technical difficulties. We love to see it, yes. And I especially love that every time I see myself frozen, it's like making the dumbest face. Um, so that's always good. All right, so I, for today's SI session, was planning at first to go through some concepts to review the semester, but I figured what better way to review than do some practice problems. So this is a packet that Dr. West gave out either last semester or the semester before, and it was kind of like a prepare for the final set of problems. So we're going to start going through that together, and I'm also going to cover this because there's no way we're going to get through all of them in this 1 hour. I'm going to continue covering them in the review session, which is tomorrow night. So let's start going through this bad boy, and if you have any questions, let me know. Alrighty, so we are gonna cover like the concepts and how to like answer these questions, but I mostly want you guys to take note of how to answer questions. So my method, I look at this and the first thing I see is MGBR. So what is that indicative of? The Grignard. Cool. And then we see here an epoxide. Cool. And so we're going to leave that for right now. We know it's an epoxide. And we know that H3O plus is an acid. All right. So at this point, you can actually start looking at the reaction. And we see this. So we have this thing plus a Grignard, which we know this is the only part we care about. We don't care about the MGBR part. So this guy is our Grignard. And so I'm just flipping it around, same molecule. So what do we know about Grignard reagents? Are they strong bases or are they strong nucleophiles? Both, neither. What do we think? Both, exactly. So how can we tell, is this one going to be a nucleophile or a base right now? It is going to be a base, exactly. And we know that it's going to be a base because of this acidic hydrogen. And just to recap, acidic H for the Grignard reaction is considered triple bonds, carboxylic acids, and on a heteroatom. And someone asked, when will it be a nucleophile? So it's going to be a nucleophile all the time, except in these cases. So anytime there's a carbonyl, it's going to act like a nucleophile, unless it has an acidic hydrogen. That's the only time it acts like a base. So in this example, we only have an acidic hydrogen. So we're just going to go ahead and steal that bad boy. And we get this negative charge, right? So now this negative charge is reacting with our epoxide. So we know that when we open up an epoxide, we have base catalyzed, acid catalyzed, etc. But does it matter which side we attack in this specific example? Yay or nay? So let me restate that. Does it matter which side of this epoxide we are going to attack when we break it open? No, exactly, because they're exactly the same. So what I will be doing is I'll number 1, 2, just so I can keep track of things. But we're gonna attack, bam, and whichever side we attack, we break that bond to oxygen. So this gets broken, and this side opens up, and so we get triple bond. Attached to the triple bond, we have carbon 1. Attached to carbon 1, we have carbon 2. Attached to carbon 2, we have an O minus. And if we have acid present, all we're going to do, wow, that was a really weird way to draw an H. All we're going to do is steal a hydrogen to protonate, and we end up with this final answer. Sorry, I didn't give myself enough room. I'm just going to move that. There we go. Hi. Hi. Sorry, someone asked me for help. Okay, back in session. Um, so does anyone have any questions about how we did this reaction mechanism? Okay, so then when we're picking an answer, okay, so someone said they do have a question in the beginning. So I'm guessing you mean like this part? I tried to do this like the short version. Okay, so the CH3CH2 attacks and it's acting like a base. So all it does is, I'm so sorry, is it steals this hydrogen and gives these electrons back here. And all we get is a negative charge here. So literally all it's doing is acting like a base and stealing like a hydrogen. And then this guy is going to act like a nucleophile. So I'll say base, nucleophile. Oh, yeah, it's probably because it's yellow and it's like hard to see. So there we go. For this example, no, it does not matter because there's no substituents. So both sides are primary carbons. If we had something like this, though, then it would matter because now this side is primary, this side is secondary. So if we have an acid catalyst, please remind me, what is the order? It's 3-1-2 because it's a pain in the ass. And what about a base catalyst? Remember our basic bitches? 1, 2, 3. Yes. Cool. So glad you guys remember. All right. So then when we look at the answer choices, the fastest way to kind of look at this, in my opinion, is all right, we know that the answer is still going to have a triple bond. All of the answers check out. They all have triple bonds. Cool. We also know that we have to have an OH, right? because this guy is going to open up to one side and we're going to be left with an OH. So we look at these answer choices, no OH, kick it out. I'll do that in red. Here we have an O CH2CH3. What functional group is that? What functional group is this? Okay, so let's draw it out real quick. So this guy would look like this, bam, carbon, carbon with a triple bond. That carbon is attached to a CH2. That carbon is also attached to an oxygen, which is attached to carbon, CH2, and a CH3. So when you see something that looks like this, that is an ether. How about something that looks like this? What functional group is that? This one's a little bit easier to see, in my opinion. And we're talking about number 3 this time. It's an alcohol. Okay, and someone actually said carboxylic acid. That's a great point. So when the way you know like quickly if it's a carboxylic acid or an alcohol without drawing it out is whether there's one O or two O's. So here it's CH2OH. If it was a carboxylic acid, it would be CO2H. Exactly. Yes. But people make this mistake all the time. I make this mistake all the time as well because sometimes when I read, I like mix things up. So it happens. Alrighty. So let's see. What functional group is this one again? And we're talking about number 4 in this one. Not a ketone. Look back at the other one we drew. Yes, exactly. So we got an ether. And this one is also going to be an ether. This one's a little bit harder to see. So we have this carbon attached to an oxygen, which is then attached to a carbon with one H, like that. So this one's a little funky looking, but it is an ether. So which one of these answers is the only one that has the correct functional group? 3, exactly. So our answer would be C, and I'll just do it here so you guys don't have to like have super tiny writing if you want to screenshot it or whatever. So we covered a couple different concepts with this one question. So we talked about the Grignard reaction. We talked about how the Grignard can be a base or a nucleophile, and we also talked about acidic hydrogens. We also did some functional group review, and we did some epoxide opening review. So any questions on any of these concepts? Sorry about that. Today's social day. People keep wanting to talk to me. Someone said I need to work on my functional groups. I feel you. I feel you. It's one of those things where it's like it doesn't feel like a big deal because it's like, oh, duh, functional groups. But then you look at it and you're like, what in the world is that? And honestly, that was the biggest thing for me on the exam was like reading this type of writing. I had to draw every single thing out every single time. And so that's why I stress to you guys so much like practice it before the exam because it takes so much time. Okay. Next one. We already did a Grignard, so I want to skip that. I want to skip that. Okay. Let's do this one. Yeah, that's a good. So, yes, that's an okay way to think about it for the Grignard equals OH because um at the end of the day, the carbonyl will always turn into an OH. Just also remember that you're adding an R group and not other things because sometimes they'll try to trick you by doing an OH but then adding like a weird group onto it. But as long as you keep that straight, you're good. So it's an R group, not any other weird thing. So if they tell you like, oh, do, oh my goodness, that was so ugly. Like they say, do this reaction, right? And then they'll give you an answer that looks like this. It's an OH and it has your group added, and that's an R group, or it'll give you something gross like this, whatever. So any other group besides an R group is wrong. OH plus R group is correct. Okay, cool. So for this one, this is a good example of like being able to read the question and figure out like what exactly is it asking you. So it's saying an epoxidation followed by reaction with base, cyclopentene. Okay. So it's saying that we're starting with cyclopentene and it says we're doing an epoxidation. So that's all that means. We go from double bond to epoxide. And so now to review another concept, what reagent do we have to use to get from here to here? Ba-ba-dum. Peroxy acid. And how do we remember peroxy acids? What was like the little trick? If you don't remember it, that's okay. But I want to see if anyone. I forgot. That is okay. So the trick is O3. Anytime you see an O3, that's going to be a peroxy acid. All right. And so now it's saying that this guy is reacting with base. So is a base catalyst going to break an epoxide? Okay, so someone really like confidently went, no, and then they went, I think, because I smiled, I assume. So someone said maybe. Okay, so remember, I'm going to erase this and pretend this top question isn't here. So ethers are stable in base, reactive in acid. But epoxides specifically are reactive in both. Super unstable. Do you remember how Dr. West was like, oh, we have the banana bonds here, and they're super unstable because of ring strain and things like that. So just remember, epoxide's super, super unstable. And if you don't want to think about banana bonds, whatever that means, right? Just think a three-membered ring. That thing is so unstable. Like a six-membered ring is ideal. This is like half that size. It sucks. We don't want it. We hate it. So epoxides will break in base and acid, but any other type of ether is stable in base. So you guys were onto something, but you weren't exactly remembering it right, which is okay. All right, so in this example, does it matter which side we attack? No, because again, these two sides are exactly the same. What does matter is which side these groups end up on. So the question here, we know that once we break this thing apart, and if we use base, you can assume that we're using NaOH. So we know that OH is going to attack one of the sides and break the epoxide open. So we know that our answer will look something like this. So first and foremost, we can get rid of this thing because what the heck does that mean, right? Like, how did we get in our group here? What is this? Gross. So we're stuck between these three, right? And the question here it's really trying to ask you is, which side is the nucleophile going to attack from, right? So if this whole thing, it has to be on the same side, right? Like it has to be on one face. So let's say they're both wedged. If this is the case, what side will the nucleophile attack from? From the wedge side or from the dash side? What do we think? Okay, so let's say both of these were wedged, right? Because we know that the epoxide has to be on one plane. They both sides have to be going the same direction, right? So for this example, let's say they're both wedged. We know that the nucleophile is going to come in and attack here, right? Is that nucleophile going to be added to the wedge side so it's the same as this? Or is it going to be added to the dashed side? Dashed, exactly. So the point of what he's trying to ask you here isn't really even about the epoxide. It's about knowing this side will stay wedged and this side will stay, or this one will become dashed because it attacks from the opposite side. But what if we had the opposite, right? What if we had, this is becoming very disorganized, I apologize. What if we had this? Now which side is the nucleophile going to attack? Is it going to come from the wedge side or from the dash side? From the wedge side, exactly. So you will get the exact opposite answer. Let me make it face the same way so it's not confusing. Oh my god. Okay. So this side stays wedged. This side is added. I think I said that side stays wedged. That side stays dashed. This side is added wedged. So we know that both of these configurations are possible. This one is not. I know that was a lot, so I'll zoom out a tad and I'll have you guys look at it. So, in summary, the point of this whole reaction is if we're breaking an epoxide, the two groups left over have to be opposite to one another. They cannot be on the same side, they have to be opposite. So the answer is actually going to be equal amounts of 3 and 4 because both of these guys are correct. Yes, exactly. So does this make sense? Okay, cool. So when a nucleophilic addition to the carbonyl group occurs, the carbon attacked undergoes a hybridization change, ... So this is a fancy way of saying if we have a carbonyl and a nucleophile attacks it, what happens to the hybridization? Yes. Okay, so it would be A because it goes from sp2 to sp3. Because remember, it says addition, not substitution. If it was a substitution reaction, what would the change in hybridization be? What do you think? Yes, it would stay sp2 because all we do is replace the leaving group with a nucleophile. So there won't be any change. It'll stay sp2. Awesome, awesome, awesome. Okay. So sure, why not? Let's do a naming one. All right, so there will be a couple naming questions on the final, most likely, and these should be your free gimme points, right? And so we know when we're naming, we start with the longest chain, and just by looking at this, I can see that this guy is going to be the longest chain. And when we are naming, the next thing we have to do is make sure that our substituents are on the lowest numbered carbons possible. So if we number starting from here, we go 1, 2, 3, 4, 5, 6, and we have a substituent on 3 and 5, versus if we start here, it would be 1, 2, 3, 4, 5, 6. So the substituents would be on 2 and 4. And I think I like 2 and 4 better because those are the smaller numbers. So let's get rid of the red numbering. All right, and the way I do this is a 6-membered chain is hex. I see an alcohol and a methyl substituent. I know that alcohol is going to take priority. And I know that an alcohol is all. So it'll be hexane all. And you can't forget the number. So it is on the number 2 position. So we have 2 hexanol. And last but not least, our methyl is on carbon 4. So we add a 4-methyl to the beginning of this name. So the answer is what? E, yes, 4-methyl 2-hexanol. Correct. Yay! All right, we're going to do number 9. It's similar to the ones we did before, but I just want to make sure everyone understands the O18 thing. So this reaction is essentially saying 1, 2, 3. Actually, I'm going to number the other way just because that's what I prefer. Okay, so 1, 2, 3. And we are using an acid catalyst, and we have H2O. So, ha is a laugh and an acid. That was a dumb joke, but anyways. So this is an acid catalyst. It stands for H acid. So when we have an acid catalyst, what's our order? 3, 1, 2. Sweet. So are we going to attack carbon number 1 or are we going to attack carbon number 2? Carbon number 1, because this one is primary, this one is secondary. So our lovely OH here is going to attack, and we get OH2. And don't forget, the one that you just added is an O18. And we know this is a plus. We know this is a minus, so we can just do an intramolecular proton transfer. And we get, I'm lazy, so I'm going to copy that. Haha. So we get this. So essentially what we're looking for is an answer choice that has 2 OHs, but the O18 is on the end. So let's go through the answer choices. We only have 1 OH, so that can't be right. We only have 1 OH, so that can't be right. So A and B are out. Here we have 1 OH, 2 OH. Here we have 2 OHs again, and here we have 2 OHs. We know that we only added 1 O18. So for that reason, E is out. And now we're stuck between C and D. We know that we added O18 to the primary side, so we need to go with the answer choice that has O18 primary, and that would be D. Any questions? Oh, okay. So someone asked C would be methyl, right? I'm not exactly sure what you mean, but C is, yes, okay. So yeah. So C is basically showing you if we had attacked this side instead of this side. So you're right. You're very welcome. All right, let's go on to a different one, like a different kind of problem. Okay, let's do one like this. So how many ethers with the formula are possible, right? And so a lot of students ask me, like, is there a formula for this? Is there like an easy way to do this? Unfortunately, you do have to draw them all out, but it's not that terrible because we only have 4 carbons. And so we can have 4 carbons, 3, 4, 5, 6, 7, 8, 9, plus an OH. Or we could do OH. Or we could even do oh, just kidding. I drew the exact same thing. That's what I meant to draw. Any other formulas you guys can think of? Can you think of maybe another function? There we go. O in the middle. Yes. So let's say we have something like this. So let's make sure the hydrogens check out. So we have 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We could also do this. We could also do, nope. We could also do this. Hold on. Oh, I apologize. This is what happens when you don't read the question. How many ethers will you have? So let's just pretend that never happened. So specifically ethers, we know that the O has to be in the middle. So those alcohols I drew, garbage. Okay, so if we have the ether in the middle, we can either do 2 carbons on each side. We can do 1 carbon and 3 carbons. Either way. Or we could do this. Nope, that doesn't add up. Okay, so besides these 3, can you guys think of any other ethers that would fit the bill? Okay, I agree. So 3 would be your answer. Please forgive the tiny stroke I had in the middle of that. I'm just really not here today. But yeah, how do we feel about this one? Any questions, comments, concerns? Okay, I'm going to assume we're good if nobody says anything. All right, this is a good one. Actually, we did one just like it, so never mind. Oh, okay, good. Which one of these is benzyl alcohol? Please tell me. Number 2, yay, because, okay, the thing you have to remember, this is a benzyl because it has that bend. It's a benzyl. And this is a phenol. So you guys were absolutely correct. This is the right answer. This is one that I like. Um, we have a ketone. Actually, practice for you guys. You tell me the functional group that I'm highlighting. Please tell me the functional group. In the least terrible way possible. I love when you guys say something and then I have this like smile and you guys immediately are like, never mind, just kidding. I take it back. No. So, for you guys that said ether, I tricked you. So, the reason it's not an ether and it is an ester, as someone just mentioned, is because we have an O2 right here. So, CO2 looks like that. So, this is in fact an ester. Don't be discouraged though. I only trick you to help you realize what you need to study. Curse these dang functional groups. I know. It's so dumb. Um, okay, so now we have a whomst. What do we have here? An alcohol. And what's this guy? So someone said, please be an ester. And before I tell you yes or no, all I'm going to say is look at this and look at this and tell me if they're the same or if they're different. They are different, yes. So the difference here is this one does not have a carbonyl, and also it does not have a CH3, it just has an H. So this is actually just an alcohol, and it looks like so. CH2OH. Nobody pull your hair out, please. It's okay. Just get some practice. You got this. What I would say to do, yes, you are right. You are not wrong. But before we actually answer this question, I will just say how I like to do it, how it kind of made sense to me is I went through all the different practice problems he has, and I turned all of the condensed formulas into drawings. And then I looked at all of those and it helped me remember, okay, this equals this functional group. This equals this functional group. And that really helps it stick. And okay, so moving on to like this actual question. Someone said this is a reduction reaction, and you were absolutely right. And so the ketone was reduced to an alcohol, and the ester was reduced to an alcohol. Are ketones and esters in the same group when we talk about reduction? No, they're not. So, in order for something to reduce both of the groups, did it have to be a strong reagent or a weak reagent? A strong reagent. So, between these two answer choices, which one is a strong reagent? Correct. It is A, because A comes before B in the alphabet. Therefore, it has to be stronger. So H2PTC, that's from Orgo 1. So I don't like this question having that answer choice. But as you can see, D and E don't make sense. So it would have to be A. You can just ignore C. That's like a confusing thing. All right. So We are out of time. I know we started a little late today, so I apologize. Hold on, let me see if there's any other like amazingly good questions that I feel like you have to know. Cool, let's do this one. Benzyl methyl ether. Tell me, which one is benzyl methyl ether? Okay, one person's locked in an answer. Anyone else? I need to review this. That's fair. But honestly, of all the things that we need to name in Orgo, I think ethers are the easiest until you get to like the methoxy, whatever. Yes, so I agree. It is number 3. So this is super simple and straightforward. Benzyl methyl ether. So ether is the oxygen in the middle. Benzyl methyl. Oh, I said it backwards. I'm so sorry. Benzyl methyl. So we get this. It drives me bonkers when people pick this one or this one, and so many people pick it. So many people pick these two. So you guys are my hope, right? None of you are going to pick 4 or 5, right? You're all going to pick the right answer for this one. I don't know if you can see the crazed look in my eye through the screen, but I can count on you, right? And nobody responds, and I spiral. No, I'm kidding. Right, don't put too much hope. I have so much faith in you guys. You guys are amazing. You're smarty pantses. You just need to not get overwhelmed, which is so much easier said than done. I know. But yeah, so we're officially done for today, I think. I think I'm starting to slowly go bonkers. So we're done for today. My biggest tips for the exam. Tomorrow we have the review. I recommend either attending or watching it just because there is a lot of stuff. Review NMR. Everyone forgets NMR. Please review NMR. Study things in chunks. Try not to flip out about it because that will kill you. The final handout. Okay, someone emailed me and asked me for it, and I just have this issue where I can't let go of things until they're perfect. It's becoming a problem though, so I will send it to you today. It might be a little ugly towards the end, but I want you guys to have it, so I will send it to you by the end of the day. I promise. This time I mean it. And yeah, that's all, I guess. We will be doing some of these questions and some other practice problems tomorrow in the review. And as always, the review will be up maybe that night if it processes fast enough, if not, the next morning. And as far as a final exam cheat sheet, I feel like it's not really necessary because you guys already have all the cheat sheets from before. Like I'm not going to make a new document, but I might just put all of those pages together so you guys have it all in one cohesive place. I'm not 100% sure about that yet, but if you guys want me to, I can. Just let me know. And yeah, that's all I have for you, I think. Today's our last SI session. I'm actually really sad about it. You guys were wonderful. So yeah, heart. I know. And the worst part about it is that you guys were all online, so I don't even really know what any of you guys look like. So if you see me on campus next semester, don't be afraid to say hi. Say hello. I will not recognize you unless you speak because I haven't seen your faces. But don't be afraid. That's it. Yeah, please just don't hug me without consent. That would be awesome. Thanks. Is there still tutoring next week? I'm not sure 100%. I thought there was, but I have to double check. If I see that there isn't, I will send out an email about it. You're very, very welcome for everything. Oh, Yeah, I'm glad I helped you feel like the world was not going to end. You guys got this. Gonna kill it. Gonna get the grade you want. I believe in you. Whee! Aw, keep complimenting me. No, I'm kidding. But it makes me very happy for you guys to say that like I helped you. So I'm so glad to hear it. And I cannot wait to see how you guys do on the final. I have no doubt that you're going to do amazing. But okay, so I will let you go now. Bye. You're too cute. You don't have to do that. Just say hello. That will make me happy. Have a good one.